In this lecture we will discuss about calculation of critical constants using Vander Waal equation. You may remember there are three critical constants. We have critical temperature, critical volume and critical pressure. So one is critical temperature, and it is denoted by Tc. It is the temperature above which gases cannot be liquefied. So if I have temperature greater than critical temperature, no liquefaction. If temperature is less than critical temperature, liquefaction is possible. Similarly, we have critical pressure. Denoted by Pc, and this is defined as minimum pressure which must be applied at critical temperature to convert the gas into liquid. So if I have a gas at critical temperature, we must apply minimum pressure of Pc to convert gas into liquid. If I have applied pressure is less than Pc at critical temperature, we cannot liquefy the gas. So in this case, no liquefaction. If applied pressure is greater than critical pressure at critical temperature, liquefaction is possible. Now similarly we have critical volume. Denoted by Vc, and this is the volume at critical temperature and critical volume. So this is volume occupied by 1 mole of gas. This is generally defined for 1 mole. At critical temperature and critical pressure. So we have three critical constants, Pc, Vc and Tc. We can calculate the values of these three critical constants using Vander Waal equation. So we have Vander Waal equation for real gases This equation can also be written as if I divide by number of moles this side, now we define V by N, that is volume of 1 mole of gas, This is defined as molar volume. That is Vm. So we can write P plus A by Vm square. This is Vm minus B is equals to R into T. Now let us expand this equation. So this square is here. So PVm square plus A divided by Vm square into Vm minus B is equals to R into T. We can further expand this equation. Let us multiply, so we will have P into Vmq plus minus V into Vm square, and we will also have P, so PV into Vm square, and then A into Vm minus A into B, RT Vm square. Now if I divide by P, so we will have so we are dividing by P. Now we can arrange these terms. First Vm to the power q. Now let us say Vm square coefficients. So here we have minus B, and here we have minus RT by P. Then Vm, then constant term. Now this is a cubic equation. Theoretically, for given any temperature and pressure, we will have three volume. Temperature and pressure, there are three volume is possible. This means if I plot pressure on y-axis and volume on x-axis, for a given pressure, basically we will have three volumes are possible. So this graph is, let us say, at given temperature T1 and given pressure, let us say pressure is P1. So there are three volumes are possible. So this is one volume, this is another volume, this is another volume. So this curve basically denotes this cubic equation. So this is a curve for cubic equation, that is Vander Waal equation. Now if you remember liquefaction of gases, you will be remembering that at critical situation we will have graph of something this kind, that is at critical temperature this will have only one volume, corresponding pressure is critical pressure, and corresponding volume is critical volume. So we can say at critical temperature there is only one volume is possible. Mathematically, this means this cubic equation will have only one root at critical temperature and critical pressure. So mathematically we can say at critical temperature and critical pressure, cubic equation will have three same roots. That is, let us say volume is Vc, critical volume, so root will be Vc. So three roots will be coincide and these three roots will be Vc. So cubic equation we can write at critical temperature and critical pressure Vm square plus Vmq plus Vm square minus B minus RT by P plus Vm A by P minus AB by P. Now we have critical pressure and critical temperature, so we can plug this value here. Temperature is critical, pressure is critical. Now this equation will be same as if I write a cubic equation that has three same roots, that is Vc. So this equation will be same as a cubic equation that has three roots, same roots Vc. That is AQ minus BQ minus 3AB into A minus B. So this cubic equation will be, so this is Q Now these two cubic equations should be identical. So let us arrange in terms of Vm. So Vmq plus Vm square, coefficient is minus 3 Vc, and then we have Vm, coefficient is 3 Vc square, constant term is Vcq. So basically equation 1 and equation 2 are identical. So we can compare the coefficients. So whenever we have two equations identical, we can compare coefficients. So let us say coefficients of Vm square, that is minus B minus RTC by PC, RTC by B. So this is RTC by B. Let us check, this is RTC by P. This should be P. So this is not B. This is P. So this becomes PC. You see here. So this is the original equation. Everywhere we have P. So this is RTC by PC. And here we have minus 3 Vc. So this equation will be V plus RTC by PC is equals to 3 Vc. we can write text equation A by Pc, that is coefficient of Vm, and here we have 3Vc square. Now constant term we have this side minus AB by Pc minus AB by Pc, and here we have minus VCQ. So we can write AB by Pc is equals to VCQ. So this is equation 5. Now from these three equations we have to calculate Pc, Vc and Tc. So let us divide equation 4 by 5. We will have A by Pc three Vc square by VCQ. So we will have Pc goes, A goes, so we will have 1 by A, 1 by B. So basically A goes, so we will have 1 by B is equals to 3 by Vc. So from here we can write Vc is equals to 3b. So we calculated one critical constant. Now use equation 5. We can calculate Pc. AB by Pc is equals to VCQ. Vc is 3v. So this is AB by Pc is equals to 27bq. So A by Pc is equals to 27b square. This means Pc is equals to A by 27b square. Similarly, we can calculate Tc. So let us use equation 3. So equation 3 is B plus RTc by Pc and this is equals to 3Bc. So we will have B plus RTc. We have to calculate Tc. Pc is given A by 27 B square. 3 into Bc, Vc is 3v. So we will have A by RTc by A by 27b square. This is equals to 8b. So from here we can say Tc is equals to 8ab divided by 27b square r. So Tc is equals to 8a by divided by 27b into r. So we have three critical constant in terms of Vander Waal constant and gas constant R, Pc, Vc and Tc. So Pc is A by 27b square, Vc is 3b and Tc is 8a by 27br. You see, Pc and Tc both depends upon A and B. So for different gases, if I know Vander Waal constant A and B, we can calculate critical temperature, critical pressure and critical volume. So if A and B is known, that is Vander Waal constant, we can calculate critical constants. So this lecture basically illustrates how we can calculate critical constant using Vander Waal equation. More about critical situation can be understood in the topic of liquefaction of gases.